watched different people explain over the years, and I'm going, what's unique here? Let's have a look at this one. I've actually written on, if that was a parabola with a 2, 4 and a minus 2, 4. If I go to 2, I go up here and I get a y value of 4. So we're talking about the x value and the y value. If I go to minus 2, I go up here and I get another 4. So they're not unique in terms of every point can't get a number repeated. So the 4 is repeated for both of them. Do you think it's going to be 1 to many or many to 1? When we say many to 1 or 1 to many, what are we really talking about? Many x's to 1 y. 1 x to many y's. Which one have we done?
1 x to many y's.
1 to many. So you can look at that and go 1 to many, and if it works for your brain, it works good. Ready for the shortcut? Ben. So many x values become 1 y value. What's the acid test for this? You ready? You're going to miss it. Country town, zoom. I put a horizontal line through and it cuts twice. I put another horizontal line, cuts twice, cuts twice, cuts twice. So if it horizontally cuts it, it's called a many to 1 y. 1 y value, 1 y value, 1 y value, 1 y value from 2 x values. So it's called the horizontal test. So when I first learned at school, did I even think about that? No. So Josh, come back to me, your eyes are drifting. If I go through this one and I start to put points on, I don't know, I could put that point, that point, that point. Am I ever going to get a repeat of the x's? Am I ever going to get a repeat of the y's? Every x value is going to be unique. X's are always changing, y's are always changing. If I did the horizontal test, does it ever double up? So that's called a 1 to 1. Now I probably should go a step further and say there's not only the horizontal test, there's also the vertical test. And it gets confusing. Do I ever get a double up? Is there 2 when I go horizontally anywhere? Is there 2 when I go vertically anywhere? Because I get to this next one and we go this test here. Now it's more obvious. This one said many to 1, but it was really only 2 to 1. Those 2 went to the 1 values. This one here, it is, if you wanted to be technical, it's 3 to 1. So that x value goes to there, that x value goes to there, and that x value goes to there. So we could call it 3 to 1, but no one bothers with 2 to 1 or 3 to 1. What do they call it? Many to 1. Now I want to slow down and say this again slowly. Say that's an x value, I don't even know what the graph is. Let's say I made that a, I don't know, the numbers aren't going to be true. So this one, for example, would have an x value of, say, I don't know, -5 with a y value of whatever happens to be, say, 2. This one might be a -3 with a 2, and this one might be a 6 with a 2. So what's happened? The y values are turned up many times. Do I think that way, Josh? I just go that way.
So that's many to 1.
Many to 1.
And that one there is many to 1 as well.
That one's many to 1, so you could jump through.
The first one.
That one's a many to 1. That's a many to 1. That's not a many to 1. That's a many to 1. So you go there and there and then there and there and you keep going, you get, so that one's an infinite number of many to 1. 2 to 1, 3 to 1, infinite to 1. One category is called many to 1. This is a big one I'll come to in a second. That one there, I could start right. By the way, that was easier to put numbers on than that one. Those numbers are fake. I don't mind the numbers being fake. This one would be y equals 4 on x. So in other words, we could write that as xy equals 4. Xy equals 4 means we're going to multiply 2 numbers to get 4. Most people think that way, and their brain doesn't accept that's just xy equals 4. So I can have 2, 2, 4, 1, I can go 1, 4, I can go 8.5, I get all those numbers into there. So this one's a bit more obvious. Is that value, that point there, does the x repeat itself anywhere? So that's a -2 and -4, that's different to 2 and 4. There's no repeat of the x's. Now let's put it this way, I'm going to put it this way. There's no repeat of the x's. You certain of that? Positive, definite? Is there any repeat of the x's? Josh? And there's no repeat of the y's. Go back to the first one. Do we have a repeat of the x's or a repeat of the y's? The y's turned up twice. No repeat of the x's, no repeat of the y's. Did the x's get repeated? No, the y's. There's a 2 there, there's a 2 there, and there's a 2 there. In some ways I should take those numbers out because I don't know what they are, but I would know that there was a 2. So Josh, if I had this graph, I don't know what graph I've drawn, but if I know it goes through at 2, 2 and 2. But they'll have the same x. They'll have different x, different x, different x, but they'll have the same y. Yeah? Go to this one. They're all unique. What's that one called? 1 to 1. So for each x, there's one y, 1 to 1. So that's a clear 1 to 1. This one, for that x, I'll get a y value. For that x, I'll get a y value, and I could keep going. And what have I got? What's repeating the y values or the x values? Y values. So I can just draw a horizontal line through there and go, they've all got the same y value. So do I think about 1 to 1, many to 1, 1 to many? No, but they've got a repeat of those. This one, the big one. So this is the only case I put them on the board, where it is. Vertical test. That one there, that one there. Do they have a repeat of the x value or a repeat of the y value? So for example, if I made that one say, yeah, we could just go do this. Let's go, that was, let's say that was 9 and that was 3. So that's going to be 9, 3, and that's going to be 9 minus 3. Which one got repeated? The x's were, or are, I should say, are repeated. What's that? One x value gave us 2 different y values. So 1x gave us what? 2 y's. 1x gave us 2 y's. So what's that called? 1 many. What test do I do? This one is a 1 to many test. We call it the vertical test. And whereas this one's called a horizontal test. Now the big one. Which ones are functions? You remember the definition of a function?
Nope.
For each value of x, there is only one value of y. Now we're talking about a function. For each value of x, there is only one value of y. So if I chop that vertically, 1, 1, 1, 1, 1, 1, chop this vertical, 1, 1, 1, 1, 1, 1, chop that vertical, 1, 1, 1, 1, 1, 1, chop this one vertical, 1, 1, 1, none, 1, 1, 1, yeah. Chop this one vertical, I'm going to do it on here, 1, 1, 1, 1, 1. So the red ones are the vertical test, and they tell us this is a function. So why is that not a function? For each value of x, there is only one value of y. For that value of x, there are 2 values of y. All my brain did when I was a kid was I just went vertical test, not a function. What's another case of not a function? Let's do a couple of them quickly. Circle. Fails the vertical test. None, none, 1. No, I can't get it, I missed it. right there, 1's supposed to be, yeah. What's another case that fails it? What about a sine graph that goes that way? Well, that's hard to draw. There we go. Can you imagine turning the inverse of a sine graph? Is that the inverse of a sine? Yes. How many times does that fail the vertical test? Infinite number of times. So that's a function, but this is not, what's it actually called, Josh, if we talk about it, 1 to many or many to 1?
That would be 1 to many.
Yeah, so your brain's seeing the 1 to many. Can you see how that doesn't work for my brain as well as vertical test, horizontal test? So this one is a 1 to many. I could go a little bit stupid and just do this for a second. Later on, when I was at uni, we had graphs like this. I can't even remember the equation of them. They come down like this, get to there, do a circle, and go back up there. Now, what's the big thing? That section there, if I use the peekaboo method, that's a function. So I can use a bit of a graph and make it into a function. Now it's not a function, and then it is a function. So what would happen with a sine graph if I turned it sideways and I wanted to make it into a function? Be interesting actually to put that sideways and see if I can get it. Maybe in degrees. So that's cause I need the sign on there always. No, I'll just draw it. So if I want to make it realistic, see how long I took to go there? I want to take that long to go there, so there it is there. Is that reasonable? Y graph and then there. Down to there, down to there, down to there. Does that look like a reasonable case? No, that's good enough, isn't it? Is it good enough for your brain?
Yeah.
I should really do this and draw it again better. You know, I wanted to go Mr. Bean method there, about there, and I wanted to go about there. Oh, that's better, isn't it? So, if I use from there to there, do I have a problem? It fails the vertical test. So it's not a function from there to there, it's not a function from there to there, but it is a function from there to there. So you can restrict that graph and say, I'm only going from there to there and I can use it as a function. So in reality, you get a situation in life where you get a curve like that that looks like it's a cubic, but it's not a cubic, turns out to be closer, or it is trig. Yeah, right? You can get restricted and say that is. Now that's a 1 to 1. Why is it a 1 to 1? I get my blue pen and red pen. Which way was it going? It passes the horizontal test and it passes the vertical test. So they're going to start asking you now, how much do I have to restrict the domain or the range? Where do I restrict it? How much do I restrict it to turn it into a function?
Oh, yeah.
So if I go back to the parabola, last bit, we've gone too long. So if I got that there, when I get the inverse, where's it go to? Instead of being that way, it's going to turn over to that way. So if I restrict it to that and I turn it sideways, what's happened? The function. So if the original is a 1 to 1, the inverse is a 1 to 1. If I turn this one sideways and I got rid of all the boxes and squares and all that, let's do it. Take my time, get it properly. Josh, can you picture in your head if I reflected that in the line y equals x? Is that a 1 to 1? When I get the inverse, it's still a 1 to 1. Why is it still a 1 to 1? That goes there, and that goes there, and it's not a bad diagram. And if I had that line through there at y equals x, through there at y equals x, so the blue one passes the vertical test, and it passes the horizontal test. So whatever was 1 to 1 becomes a function. So I go back to here, if I had that bit there, it would, if I had just that bit there, I'd be okay. But when I got the whole shape, what's my problem? Ready? Watch me do it. That becomes that. You okay? Then it fails there. Very good first. Bam, concepts. Fail, see? But if I did this, now I test my brain. See, when I do this, I can just go like that. So what happens? That arm becomes that arm. And then it passes the test. Well, go, this arm, Josh, this is the big one. They want you to mention both. List 2 restrictions of the original parabola that makes it into a function. Left arm becomes a function, right arm becomes a function. But what if I moved everything sideways? Still the left arm becomes a function, and still the right arm becomes a function. What happens with a cubic, a stretched out cubic, that way? Not a problem. What happens with a cubic that goes like that? Problem. Enough said. Can you imagine what they're going to do with cubics? You can go the bit in here, so you can go from there to there, and there's 3 sections. Yeah, you see it? So you could say I could go from there to onwards, I could go from there to there, and I could go from there to there. So Josh, there's 3 answers to that one. Enough said. That's too much. I don't know if it's any good. It might work for the people who are away, but I don't know if it's any good. Poor Joshy.